Okay, good morning, everyone. I hope you guys had a good weekend and any questions from the homework I assigned? Why 39? Okay, we'll do that. Before we do, answer your question, I just want to recall the equation of the circle because we will use that. So a circle, the Cartesian coordinate of a circle is x squared plus y squared equal r squared. So that's if you have a circle centered at the origin and with radius r, then the equation of the circle is x squared plus y squared equal r squared. Now, if you have a circle, but not centered at the origin, okay, centered at the point hk, so this is my circle. And the radius is r. That's the radius. Then the equation of this circle is probably some of you know the equation of this circle, and we will talk about it later on, probably sometimes next week, will become x minus h squared plus y minus k squared equal to r squared. Okay, so those equations may come up with us in this chapter, so we have to be aware of them. All right. With this in mind, I look at your problems, number 15 and 25. Now, as you guys realize, for those you who look at the homework, I'm starting to give you old problems. It means since in 2 weeks, you guys have your final. So I'm going to use this opportunity to assign every time new material, but it's not because it's not a hard material, and I will assign problem from the old material. So I will be doing this for the next 2 weeks. That's really how I will be doing this, just to help you out. So what I did last time for today, you guys had problems from this section, of course, and I assigned integration by part. And the idea is that I want you to start reviewing those. And for tomorrow, I'm assigning other integration problem. And I will do that for the next 2 weeks. So please do review, use this as an opportunity for you to review, because the course is so scattered. It's like 4 different pieces. So sometimes we tend to forget a piece we've learned. So use this opportunity to actually review for your final. So I will start with number 15, because I think this is relevant to my section. Number 15, what is this? Okay, so the question is, we have 2 equations given parametrically, 3 plus t and y equal 1 minus t. And my t goes between 0 and 1. Okay, so it means we have a curve, and at every time t, that's the way you should think about it, because it helps you. The idea is that imagine t represent time. So imagine this in your mind. And you have an object which is moving along with time, where time goes from 0 to 1. And at every time t, that's the x coordinate of the object and the y coordinate. So x and y tell me where the object is at every moment in time. Now the first question is, eliminate the parameter and find an equation that relate x and y. The way we do that is we solve for t in one equation in general, and we substitute in the other. This will give me an equation that relates the x and y that holds regardless what t is. So for example, I'm going to take, it doesn't matter which one you start with to solve for the t. Suppose I take the first one. I say, okay, x, for every moment in time, x is equal 3 plus t. Means t equal x minus 3. So I'm trying to find the relation between x and y independent of t. And then I plug it into the expression of y. 1 minus x minus 3. It means y equal minus x plus 1 minus 2. Okay. So what this equation tells me, it doesn't tell me how is the object moving. It only tells me that the actual motion occur on this line. That's what it tells me. The motion occur on this line, but it doesn't tell me how we're moving on this line, in which direction, when do we start. And this is, we have to go to the parametric equation to figure this out. But first, that's where we're moving. So y equal minus x minus 2, that's in line. We start, no, I have a stupid mistake. Minus x plus 3. So we're starting at 4. And the slope is minus 1, so this is my line. Okay, it means I am moving on this line, but the question is, part B is, describe the curve and indicate the positive orientation. All right, what do I mean? Okay, between t and 0, 1 here, I'm going to take some values to figure out when we're starting and which direction we're moving. So at this stage, I have to take some values of t and figure this out. I say, okay, at t equal to 0, this is a 3, so I'm plugging it in here, and this is a 1, because t is from 0 to 1. These are the only value I will take. So if x equal to 0, t equal to 0, x is 3. So we know that this should be a 4 in here. So it's a 3 and 1. So t equal to 0, actually it's down, should be down here. Here. T equal to 0, this is the point 3, 1. So we're starting right here. That's at t equal to 0. And then at t equal to 1, we know we are on this line, but I don't know which direction. If t equal to 1, my x is 4, and this is 0. For t equal to 1, x is 4, and equal to 0 means you're moving this way. So basically, this piece is irrelevant to me, and this piece is irrelevant to me. So the motion goes from here to here. So now I draw it one more time to be very clear with it. So at t equal to 0, we are at 3, 1. That's where we start. At t equal to 1, I am at 4, 0. And I know that it's a line, so it's not curving. So this is the motion. We start here, we end up here, and this is the positive direction. So that will be the exact motion we have. Okay, so this told me that it's a line. And this tells me, how we are moving on this line. Now, let me be very clear with you. It's not always easy to find an equation that relates x and y. The problem we're doing, we will be able to, but in general, it's not easy at all. And most of the time, the curve is given only in terms of a parameter. We're not always capable of doing this, except the problem that they are giving you in this book. Questions before I go on? Let's look at number 25. Number 25. Okay, so we have x equal. So instead of calling the parameter t, they called it r. And y equal r cubed. And my r is between -4 and 4. Okay, part A is to eliminate the parameter. So how do you want me to eliminate the parameter? So how can I find an equation that relates x and y that is independent of t? It means no matter what t is, I have this equation. Anybody quickly wake up?
R equals
Solve for R.
What?
We could use the first equation to get r equals x plus 1.
Right, that's the easy one. I mean, I won't use the cubic root. Why would I do that? I use what's easy. Yeah. Now I have r, now I plug it in here. To the power, I meant x. X plus 1 to the power 3. So now if I graph this tell me that where the object is moving. Only. It doesn't tell me, as I said several times, how is the motion, but as when the object is moving, x plus 1 to the power 3, this is like, that's x cubed, and just x cubed, you're shifting it. So it's something like that. So that's really the direction of motion. Not the direction, that's where the motion is. That's where the curve that the object is moving on. B is, we have to study a little bit, how is it moving and what's going on. All right, this is when I start plugging some value. I don't need a lot, but enough to understand what's really mathematically going on. So for t, x, and y. Now I'm starting from -4 to 4. So at -4, what is my x? -4 minus 1, it's a -5. And -5 to the power 3, which is 125. And it's a minus. Okay, so at 0, and then I'm at t equal to 0, I am at -5 and down here, somewhere here. It's out of scale, but that's really what's happening. So this is t equal to 0. Let me take, let me take, this should be r. And this is r minus 4. I'm goofing a lot. Now, r equal to 0, just to see in between where I am. X is -1, and this is 0. So at r equal to 0, x is -1, and I'm right here. And r equal to 4, we have 4 minus 1, which is a 3. And 4 to the power 3 is 64. And this is minus 64 right here. Okay, and this would put me somewhere here. So this is r equal to 4. Okay, so basically the object is starting from the 64, sorry, starting here and moving this way. That's the motion of the object. And another analysis that sometimes it's really actually helpful is to think about it that as r goes from -4 to 4, x is actually increasing. It's starting right here. X is increasing. It means you're moving to the right. Y is increasing. It means we're moving up. So we're moving to the right and we're moving up at the same time. Okay. All right, I will do one more problem. I don't know if I assigned it or I didn't, or you didn't ask. I don't really know, but I would like to do it. Number 23. We have the following. X equal cosine t. Y is 1 plus sine t. And the t is between 0 and 2 pi. Okay. All right, so this is my curve right there. And the question is first, that's what they want. Find the equation that relate them. And the second is, what's the direction of motion? All right, so part A, which is that's why I'm doing this, because we haven't seen something like that before. And I don't know if I assigned it. I thought I did. I don't remember. So how can I find an equation that relate x and y?
Would it be the inverse of cosine? Like arc cosine? Or
mathematically correct, but it will not give you the shape. We're going to do better than that. We have to do better than that. The only hint I will give you is that whenever you have cosine, not all the time, but most of the time, this should guide us a little bit. Let's see if this is a good hint. Yeah, but how can I use this, Elizabeth? I hope you're feeling better. How can I do this? Okay, here we are. Okay, let me see what your classmate is suggesting. X is cosine t. From this one, so I'm not going to touch it for a minute. Y equal 1 plus sine t. Okay, I'm going to isolate the sine. This would give me y minus 1. Okay, and then I have the cosine, which is x. Okay, so whenever you have sine and cosine, most of the time, as I say, not all the time, it's nice to isolate the sine and isolate the cosine. Because when I do that, then if I say, okay, the cosine square plus sine square is 1, regardless what the t is. So that's an identity. It means this will going to give me x squared plus y minus 1 squared equal to 1. And this would be the relation that exists between x and y. Now, this is the equation of what? This is the equation of what?
Of a circle?
That's a circle. Of a circle. Means if we draw all the points that satisfy this equation, we're going to get a circle. And the center of the circle and the radius. Okay. The center is 0, this is a 1, and the radius in this case is 1. Okay. So this represents the motion of an object. This tells me where it's moving, as I said, not the direction, nor what is start, only when it's where it is moving. And it's the center at 0 and 1. So that's a 0, that's a 1, that's the center, and the radius 1. So that's where the object is moving. Okay, so that's where the motion is. The motion is right on the circle. Okay. Part 2 is the direction of motion and where the object is moving. So we have two parts of it. So we know it's moving on this circle, but now what's the direction of motion? So t is between 0 and 2 pi. I'm going to start taking values of t, and not a lot of them, because I know where the object is. I want to know the motion of it. How is it moving? Clockwise or counterclockwise, and where it starts and where it's at. So I'm going to take my little table. So this is for part B. Some values of t, the x values and the y values. Okay, at t equal to 0, my x is the cosine. Cosine of 0, it's a 1. My y is 1 plus the sine, which is a 1, because sine of 0 is 0. So at t equal to 0, I am at 1, 1. I know I am on the circle. This is the 1, because that's the center here. So it should be right there. So at t equal to 0, I am right here. And then how is the object moving? Is it moving clockwise or counterclockwise? What do you think? How do you think I'm going to answer this question? I'm moving this way.
Solving for 2 pi would it be?
2 pi. Okay, watch 2 pi. I'm going to put it here. Let's see why 2 pi is not relevant. Why do you think 2 pi is not relevant?
The same as 0.
Right, it's the same as 0.
Use pi over 2.
Right, I have to take something in between. Okay. We have to really understand at 2 pi is the same 0, it's a 1, 1. Let me try pi over 2, for example. At pi over 2, the cosine is a 0. 1 plus the sine, which will give me a 2. So I am right here. So we're moving this way. Okay. Another way you can think about it, you say, okay, as t increases, what happened to x? And what happened to y? So one way you can plug in point, and we did. Another way you can ask yourself, when t increases, what happened to x? Does it increase or decrease? Let's try to imagine x is the cosine of t. What happened to cosine of t between 0 and pi over 2? That's the cosine. Start here, goes down. That's the graph of cosine. So as t increases, the cosine actually decreases. It means the x is going to decrease. So we're going basically to the left because the x is decreasing. But if I go to the left, I can go up to the left and I go down. So I'm going to go to my y and see what is my y telling me. Is my y increasing or decreasing? Y is 1 plus the sine. Now the graph of sine start from here and it goes up. So between as t increases up to pi over 2, the sine is increasing. So 1 plus the sine is increasing. It means y is increasing. So y is right there increasing. It means the y has to go up. My graph is going in this direction. Okay, so you can plug in values, or you can a little bit analyze what's really going on for x and y. And if we keep the same analysis, you realize that we're going to do that. So it's going to move counterclockwise on the graph. Now, let us say, for the sake, let us say I tell you, please ask question as we move on. Parametric equation will play an important role in calculus 3. Very important role. Now, let us say my t is between the parameter t between 0 and 4 pi. Okay, so between 0 and 2 pi, we started here, we went around the circle. If you are between 0 and 4 pi, what do you think will be the effect on the graph? What do you think happened if I let the parameter t go from 0 to 4 pi?
Would we go around the circle twice?
We will go around the circle twice. We will go around the circle twice. Between 0 and 2 pi, we start here, we move. If think of t as time, because it's a very good, it move at 2 pi, I am back here. But we know after that, so when I started between 2 pi and 4 pi, the values of cosine and sine will repeat themselves. It means the x and y will repeat, and then I'm gonna go around the circle a second time. Okay, so if the parameter between 0 and 4 pi, I start here, I go around the circle, then I do it again. So I go around the circle 2 times. Those are information we never get from this equation. This just tells me you are on the circle. That's it. But this tells me exactly how many times I'm going around the circle, where I am starting. I'm starting at t equal to 0, and so on and so forth.
So the values don't change, but they repeat twice. So
Exactly.
it goes around the circle twice. Okay.
Exactly. The values don't change because the cosine will not change, the sine will not change. So the x and y will remain the same. But you're going around the circle a second time. So if you think about t as time, as I said, it means somebody running around the circle twice, which is different than running around the circle once. Okay, so that's the effect of the parameter. All right? So, okay, I look at point 8.239. Those problems, I will just look at them. I guide you, but I don't finish them because otherwise I will never finish the course. So 8.2 number 39. As I said, I will just guide, and then you guys will have to try to do them. 8.2 number 39. Okay, it was the integral from 0 to 1 of sine inverse of y dy. And this is the typical integration by parts problem. So we have a u and a dv. Okay, so what do you think is going to be the u in this problem? And what do you think is going to be the dv in this problem? For those who tried the homework, you have to start scratching your mind and remember integration by part. What's the u? Anybody?
Inverse sine of y.
Exactly. That's going to be my u. We don't really have a lot of choices. dv is always the leftover part. Okay. And remember, integration by part, I should be able to find the antiderivative. So I cannot put u dv to be the sine inverse because I really don't know its antiderivative. So this would give me the du is 1 over the square root of 1 minus y squared dy. And this would give me v to be the antiderivative, which is y. Now we have to find u apply. So it's going to be give me d. The integral, and I worry about the limit at the end. Don't worry about the limit. It's uv, it means y. So if I put this is from 0, 1, it means we evaluate this from 0 to 1 minus the integral from 0 to 1 of v du. It means y over the square root of 1 minus y squared dy. Okay, this is easy because this is you only evaluate at the upper limit sine inverse of 1 minus 0 minus. How do you do that? Very quickly. Very quickly, how you find this?
U substitution.
That's U substitution. U substitution, where the U is 1 minus y squared. Okay, and then you finish the problem. Okay. And remember, sine inverse of 1, the angle this will be the pi over 2 minus 0, and this you just do a simple U substitution and of the problem. All right. So today we are going to keep going with parametric curve. There's two things I would like to talk about. First, I'm going to ask some questions, and I'm going to a little bit do the reverse of what I did before. So let me, the question is, find the parametric equation of the following. Okay, so let us say I have a circle centered at 0, 0, centered at the origin with radius 4 and generated counterclockwise. Okay, so what am I talking about? It means I have a circle. It's centered at the origin and the radius is 4. My question to you is, I want you to find the parametric equation. Now, I'm not going to give them to you and tell them, okay, this is the parametric equation. Find the curve and direction of motion. This time I'm giving you the direction of motion. I'm giving you the circle, so it's counterclockwise. And I'm asking you, what's the x? What should be a y? So when I, as a function of t, so when I graph them, I get the circle. Just the reverse of what we did a minute ago.
Would x be cosine t and y would be sine t?
Repeat.
X is cosine t.
Cosine t, y, sine t, right?
Yes.
Okay. Let me see if you're correct and how you're going to fix what you have. If you fix this, we are in a good shape. According to you, what we're going to have? X squared plus y squared will be what? According to you?
16.
No. Where is the 16 coming from? According to what you told me, x is cosine, y is sine. So x squared plus y squared will be what?
1.
1. What do I want? The radius.
16. I mean 4.
4. How can I fix what you gave me?
Oh.
Are you with me?
Yes.
Okay.
So would we divide everything by 4?
We divide what by 4? Anybody can help a little bit?
Would it be 4 plus sine of t, like an initial equation?
No. I'm going to go through every scenario you gave me and fix it. See if 2. Suppose, okay, 4 plus. That's what you want? And 4,
The sine.
and 4 plus. But then I need to isolate the cosine and I need to isolate the sine. This is going to give me x minus 4 for the cosine. And this will give me y minus 4 for the sine. So according to you, I'm going to have this squared plus this squared equal to 1. That's not a circle centered at the origin. That's a circle centered at 4, 4 with radius 1. Are you with me?
Yeah, I got it.
Okay. Now,
you have x equals
the
4.
last scenario. Once I do it, it becomes repetitive and you guys will memorize it. So we want, basically, we want x squared plus y squared to be equal to 4. Right, exactly. It's going to be 4 cosine and 4 sine. Okay, this would give me the 4. So let's see why. I mean, I can give you 2 reasons for that. One reason is, suppose I take x squared plus y squared. What do I get? 4 cosine t squared plus 4 sine t squared. It means 16 cosine squared plus 16 sine squared. Now, if I factor out the 16, I have cosine squared plus sine squared, which is equal to 16. It means x squared plus y squared equal to 16. That's a circle of radius 4 centered at 0, 0. Okay, so to get a circle of radius 4 centered at 0, 0, I need x equal 4 cosine, y equal 4 sine. Not plus, it's just multiplied by 4 sine and cosine. Very good. Now, I want it to be generated counterclockwise, and I want my interval. So let us say I want to go around the circle once. So what is my interval? T. So I want T between where and where? And then I want to make sure is I'm going to generate it counterclockwise. So let us say T from 0 to 2 pi. Okay. And now am I gonna, so this is my parameterization. We are creating the parameterization now. And then does this go around the circle once, counterclockwise? Okay, at t equal to 0, x is 4 cosine 0, which is a 4 and 0. So at t equal to 0, I am right here. At t equal pi over 2, this is 0 and this is 4. So I'm going this way. So this is a correct parameterization, right? So if I give you the circle, I tell you find a parameterization. The parameterization for a circle of radius 4 is 4 cosine, 4 sine. And this is the parameterization that gives me counterclockwise going in this direction. Now I'm gonna have a, since we built the circle, now suppose I want the following. I tell you same question. But suppose I want it to be generated not clockwise. So I'm gonna manipulate a little bit so that I can go around the circle. But I want it to be go around the circle clockwise. Okay, how can I play around with the x and the y?
Won't the x and the y stay the same?
They stay the same. I will go counterclockwise. How can I
Make them negative.
take them negative? So you're gonna come up with a lot of scenarios. Suppose I take them negative. Okay. All right, now one benefit if take them negative is the following, because if I want to start at here, in this previous problem, t equal to 0, and then we move this way. If I want them clockwise, I can say, you know, I want to move that way. Means I want the x to be negative. I want x to stay positive, actually. Why negative? So do you think this would do? Okay, let me follow that. This x squared plus y squared will be equal to 16. So I am on the circle. And if I follow this scenario, and then you guys will tweak it for me. Let's see if I move this way. T, x, and y. At equal to 0, minus, I will have a minus 4. Y will be a 0. So at equal to 0, I'm going to be starting right here. Okay, according to the scenario. At equal pi over 2, so I'm going to follow that. I'm going to get minus 4 pi over 2. I'm going to have a 0. Sine pi over 2 is 1. I'm going to have minus 4. So at equal to 0, I'll have 0 minus 4. So is it working?
No.
No. How do you tweak it?
Take the negative away from negative 4 sine t. So it should just be negative cosine t.
So you want to keep the negative here, make this positive?
Yeah.
I'll think the other way around.
The other way around. And let's see why. Other way around. Because if you're going to start here and move, is the x going to be negative or positive? As you move a little bit. My x is going to remain positive. My y is going to be negative. So I'm more likely to fit this scenario than that scenario. So let's try this one, 4 cosine and minus 5. So basically it's the opposite of that. If you look here, 4 cosine and 4 sine, we move this way. Now I want to move basically in this direction, right there. So I say, you know, I can keep the x the same, but I'm making the y to be the negative. And then I am more likely to move the other way around. So let's see if this scenario would work. So I'm going to take my values now. Okay, at t equal to 0, 4 cosine, that's give me the 4. And that's a 0. So I'm starting here. At pi over 2, that's giving me a 0. And that's giving me a minus 4. So at pi over 2, I am right here. At t equal to 0, I am right here. And in between 0 and pi over 2, I know the cosine is positive. The cosine is positive means the x is positive and it's decreasing, which is what we expect. And the sine, since it's a minus 4, the sine is like that. It means the sine is negative. That's the y component. It's negative and it's getting more and more negative heading that way. Okay, so that will be the same. It will generate a circle, this parameterization. And the difference is that it will generate it but clockwise. So you can go around the circle counterclockwise. That's scenario number 1. If you want to go around it clockwise, that will be the scenario number 2. So we keep x and we change y. Okay. The other variation before I move on is I'm going to give you the following. Same question, but. So same question as before, but now I want the following. Generated counterclockwise, but start at the top. Let us say 0, 4. So basically, that's what I want. I want to start here. I want here to be t equal to 0. I want it to move clockwise, counterclockwise. Okay. All right, so what's the x and what's the y?
Aren't the x and the y going to be the same as the first problem?
Can you switch the x?
Well,
and y?
Yeah, I
or
can.
cosine.
What do you want me to put here? It has to be the sine and the cosine. Let's get that straight.
Yeah, so x should be 4 sine.
X should be 4 sine. Why did he think that? Absolutely correct. Why 4 sine is a good idea in this problem?
because for sine of 0 will give you 0, and then
Right.
y for cosine will give you
Exactly,
1.
because for t equal to 0, it's the sign which will give me a 0, and that's where I want to start. Now, there are a lot of different ways. We're doing one approach, that's going to give me 0. And this is going to be the cosine. Because at t equal to 0, the cosine will give me a 1. Now, I have to make sure that we are moving counterclockwise. Okay, is this the correct motion? So this is a circle, because if you take x squared plus y squared, again, you get 16. So I am on the circle. This is satisfied. And now, am I starting here and am I moving this way? So we can take points. Say, okay, this is t, this is my x, and this is my y. At t equal to 0, sine of 0, that's why he picked the sign, because we want this. So sine of 0 is going to be a 4. Sorry, 0. The cosine will be a 4. So I am safe. I'm starting here. Question number 2, am I moving counterclockwise? So I'm going to take, let us say, pi over 2, because those are easy values. At pi over 2, the sign is, this is a 4. And so that's the x coordinate. The y coordinate is equal to 0. So the x is 4 and the y is 0.
So then just make sine t negative. So negative.
Make sine t negative. So we're really starting from scratch, and then we play with it a little bit. Minus 4, 0. And then I am here at t equal pi over 2. And the rest is absolutely correct. Okay. And the reason minus 4 makes sense, because as t increases, if I want to go counterclockwise, my x is negative. So I want to make sure that I'm getting negative in here, and then cosine t. Okay, so trial and error. You try something and you start fixing it a little bit. The guideline is either x is for sine, y for cosine, or the other way around. It doesn't really matter whether you take sine or cosine. What the effect of cosine and sine is really where you start and the direction of motion. But the idea, either for sine for cosine, or for cosine and for sine, and plus and minus to fix the problem. Okay. All right. Now what we're going to talk about is an easy idea, is tangent line to a parametric curve. So tangent line to a parametric curve. Tangent line to a parametric curve. So that's all the same section. All right. Let us recall a little bit. Let us recall from calculus 1. Okay. Let us recall that. If y is a function of x, so I have the simple scenario where y is a function of x. So I have a graph and y is a function of x, then the slope of the tangent line at a specific point, if I take a fixed point, and what's the slope? Now, if you guys remember, to find the slope of this tangent line, the way we did it, we took a point nearby, and we found the slope of this point. That's really what we did from here to here. So we found the slope, and then we let the interval delta x become smaller and smaller, and we find delta y over delta x over a smaller and smaller interval. So the slope of the tangent line is the limit as the change in y become very small of the change of y over the change in x. And we denoted this by dy dx. So if y is a function of x, and the slope of tangent line, which is nothing more than the derivative, that we know that. So that's a change of y over the change in x when the change in x becomes very small. Now, if a curve is given parametrically, I don't necessarily have y as a function of x. I have y and x and y in terms of parameter t. So I cannot use this. So if a function is given, if a curve is given parametrically, then y is not necessarily a function of x. So I cannot use f prime. It's not necessarily a function of x. Sometimes we have a circle. If we have a circle, like here, y is not a function of x, because for every x, I have 2 y's. So it's not really a function of x. So y is not necessarily a function of x. So the question is, what's the derivative? Or what's the slope? So the formula for, I will give you the formula for the slope. So however, we have the following. So if you have a curve given parametrically, that's my curve, it's given parametrically, for if that's in this case, y is not a function of x, but it's given parametrically. It means that every time we have basically the position. So, but we still have a curve and we have a tangent line. So this is the formula. Then the slope of the tangent line, it's going to be equal to, it's always dy dx. So it is the change of y over the change in x. So the approach, the definition will never change. It means we take a point and we evaluate the delta y over delta x. That's the same thing. But the idea is now here, I don't have one formula for y as a function of x. So this is going to be equal to, we'll go by the following formula is dy dt, the derivative of y with respect to t, divided by dx dt. So I don't have y as a function of x, I have y and x in function of a parameter t. So the slope will have this formula, where wherever the x dt is non-zero. Okay, so if y and, so if x and y are given of a parameter t, and I want the slope of the tangent at any point, that's exactly what we're going to use. So a very quick example, because it's actually simple. Example. Suppose I take the following curve. X equal t squared plus 1, and y equal t to the power 3 minus 40. Okay, now if we graph this curve, we get something like that. This is a neat curve. We get something like this. And there are a lot of decimals. If you guys are familiar with decimals, they draw those curves very nicely. And your calculator also does it. So if we draw all the points that satisfy this equation, we get actually a curve like that. It's kind of wiggly. All right. And as you realize, for x, I have two different y's. So y is not really a function of x because we don't have one y for every x. Okay, that's really why we study those parametric curves. Now the question is, question number 1, and that's now it's easy. Find slope of the tangent to the curve at t equal to 2. Okay, all right. What's the slope of the tangent at t equal to 2? Before I find the slope, let me ask myself, at t equal to 2, where am I on the curve? So if t is equal to 2, x is how much? 2 squared plus 1, so that's x is equal to 5, and y is equal to, what's y? T to the power 3, which is 8, minus 8, which is 0. So at t equal to 2, x is 5 and t equal to 0. So basically it seems to be right here. All right, now the slope. What's the slope? The slope is, which is dy dx. We use the formula verbatim. It's dy dt over dx dt. So it's mean equal to, what is dy dt? Dy dt is 3t squared minus 4, exactly. What's dy dt? Dy dt is equal to 2t. So now at t equal to 2, so that's the slope in general. At t equal to 2, the slope is 3 times, I plug in 2 in here, minus 4 over 2 times 2. So it's going to give me 12. 12 minus 4, it's 8 over 4, which is equal to 2. Just a coincidence. We're getting the same value unless I am goofing somewhere. Okay. Question number B is, so 5, 0, it's somewhere in here because that's the point. It should be 5, 0. And the slope is 2. So that's my tangent line right there. That's my tangent line. And the slope here is 2. Okay. Question number 2, find the equation of the tangent line. Tangent line at t equal to 2. So basically, I want the equation of this line. All right. For equation of a tangent line, we need the slope. Just remind you, calculate. The slope is equal to 2 by coincidence, the same number. It doesn't have to be. And I need the point. The point is that, because that's where I am on the graph at t equal to 2. So the point is 5, 2. I'm at 5, 0. So the equation would be y minus y0, the slope x minus 5. So would this give me y equal to x minus 10? And of the problem. So finding the equation of the tangent line is actually simple. Once this is the equation, which gives me the slope. If I want the equation, I know the slope. I can find the point. I get the equation. Okay, I stop right there. As usual, anybody has a question can stay. Otherwise, the class